we name our angles with capital letters, and we name our sides with lowercase letters that are opposite that capital letter. So angle A is opposite side A, and angle B is opposite side B. What side is adjacent to side A? B. Okay. And what side is adjacent to side or to angle B? A. And what do we call C no matter where we're standing? The hypotenuse. Yes, that is the hypotenuse. So opposite and adjacent can change, but a hypotenuse is a hypotenuse no matter where you're standing. Okay? It's always the hypotenuse. Right triangle trig, actually all trig, is a ratio. It's how this side relates to that side, this side to that side, or this side to the hypotenuse. So it's a ratio, how they relate to each other. Does anybody remember our three basic trig functions?
Yes.
Sine, cosine, and tangent. Alright, so sine. What's the ratio for sine? Opposite over hypotenuse. Opposite side from where you are standing in relationship to the hypotenuse. How about cosine? Adjacent over hypotenuse. You know, the adjective, that's the other class. On this side of the building, it's adjacent. Yeah. How about tangent? Opposite over adjacent. Those are our three basic. We're going to actually cover all 6 of them today. Do you remember our mnemonic device for sine, cosine, and tangent? Krakatoa? Alright, we also have reciprocal functions. Reciprocal functions are just that. They're the functions that are the reciprocals of these three functions. Remember what a reciprocal is? Not opposite, because that would change the sign. Flip it, yeah. Flip it. I don't want to oppose anything. I don't want to make it opposite change the sign. Alright, so the reciprocal function for sine is cosecant. And it would be hypotenuse over opposite. See how that works? Cosecant. Can you spell it out? Like that. And then the reciprocal function for cosine is secant. SEC. Guess what it is? Oh my gosh. Are you psychic? Alright, and then there's cotangent, which is adjacent over opposite. Memorize these. Memorize all 6 of these, okay? The first 3 you should have, and the next 3 should be just very quickly derived from the first 3 until you can just get them out easily. Secant. I think You also did the same one. Alright, memorize these. Get them in your brain, okay? Um, we'll have a quiz over just these, but not just that. Um, later on, especially when we start doing trig identities, you have to interchange them so much. Like, you just have to be able to look at it and know, oh, well, that's that and that's that. Another way to look at it is cosecant is 1 over the sine. Secant is 1 over cosine. Cotangent is 1 over tangent. Sine is 1 over cosecant. And those of you going on to calculus, it's just absolutely invaluable. You've got to be able to have these completely ingrained in your head. Alright, can I move this? Do I have it? Alright, list for me the 6 trig functions for angle A and for angle B. 6 trig functions for each of those. So let's talk about sine of A. What's the sine of A? What's the cosine of A?
4 over 5.
What's the tangent of A?
3 over 4.
Which one did you do next? Did you go back up and then do
I did
cosecant?
I did cosecant.
Cosecant of A would be,
5 over 3.
and secant of A, and cotangent of A.
4 over 3.
Alright, now let's talk about B. How about the sine of B?
4 over 5.
And the cosine of B?
3 over 5.
And the tangent of B? Right, and the cosecant of B?
4 over 5 over 3.
And the secant of B?
5 over 3.
And the cotangent of B? What?
3 over 4.
Alright, what do you notice here? What do you notice here?
Oh.
They're the same thing. Does that work for like any angle ever? Why does it work for these?
Because they're right.
They're not right.
I mean, it's a right triangle.
They're complementary. Okay? They're complementary. Complementary angles oh, good heavens. Could that word be any longer? Complementary angles. Complementary angles. Here, let's name them A and B. Make it easier. So the sine of A equals what? No. The sine of A, for any complementary angles A and B, the sine of A is going to equal the cosine of B. Why does that work? Right. One's opposite is the other's adjacent, right? One's opposite's the other's adjacent. Okay. So the sine of A, the sine of B would equal cosine of A. The tangent of A equals what? Cotangent of B. And the tangent of B equals the cotangent of A. What about secant? Secant of A, what does it equal? Secant equals secant? Cosecant of B, and the secant of B equals the cosecant of A. Did we cover them all? 1, 2, 3, 4, 5, 6, 7. Alright. So let's say I have I lost my calculator and I have this chart, but then my little brother tore the chart, so it stops at 50 degrees. That's as far as the chart goes. But I need to know the tangent of 77. How can I use my chart and find the tangent of 77 if my chart doesn't go to 77? What can I look at?
It's opposite.
Why 20 degrees? Okay, its complement. You can look at the cotangent of its complement. See? These are any complementary angles, A and B. So if I needed to know, the sine of 80, well, I don't know the sine of 80 because my kid brother chart off, it only goes 50. But I really have to have the sine of 80. What do I need to look at? 10's what? I need the sine of 80 would equal the what? The cosine of 10. See, the sine of A equals the cosine of B. A and B are complementary. They equal 90. So whatever gets them added together to equal 90, that's what you look at. Alright, everybody have that? Alright, let's just see what we remember about our special right triangles. There's two special right triangles. Okay? There's the 45, 45, 90. And the 30, 60, 90, right? So remember what they are. Remember what's special about them?
Yeah, we got one of them's one side.
Like if this is 1 and that's 1,
So
then what's this? This is the square root of 2. Okay? And see, it doesn't matter. These always have the same, because it's a ratio. If this is 5 and that's 5, and this is 5 times the square root of 2. So when I start putting things over each other, like if I want the sine of 45 degrees, and I do opposite over hypotenuse, I'm going to have 1 over the square root of 2. But what if you use the 5? Okay, well I'm going to have 5 over 5 times the square root of 2. What's going to happen?
I'm so confused.
What?
What did you just say? Because I got lost because I was still learning it.
If these are always the same, they're always the same. The sine of 45 degrees is 1 over the square root of 2, which we're not going to leave it like that. We're going to rationalize it. If I had 5, 5, and 5 times the square root of 2, it's still going to be 1 over the square root of 2. Because if you put 5 over 5 times the square root of 2, 5's cancel out, and you're left with 1 over the square root of 2. Okay? So for sine and cosine, cosine's going to be the exact same thing. of 45 degrees, just on this one, it'll be the exact same thing. And it's going to be square root of 2 over 2. You've got a rationalized denominator. And what's tangent going to be for 45 degrees? 1. Tangent's 1. Tangent 45 degrees is 1. Because at 45, 45, 90, those two sides are exactly the same length. Opposite and adjacent are exactly the same. It doesn't matter if the triangle is 1 by 1 or 1,000 by 1,000. They're exactly the same. And when you put your opposite over your adjacent, they cancel out and you're just left with 1. Alright, do you remember your ratios for your 30, 60, 90 triangle? It's something to the square root of 3, yeah.
Is it like the one, it's double, and then it's whatever it is.
Alright, this one is A.
So
Call that one A.
And then it's A, 2A,
What's 2A?
the
Line.
other leg.
Nope.
Hypotenuse.
Hypotenuse is 2A.
It's A squared, yeah.
A squared root. Right, that's your special right triangle. Alright. Special. Really special. So these are some that you're going to just use and memorize. Sine for 30 degrees is going to be of any right triangle. What's sine of 30 degrees? It's the cosine of 60, but what is it? Alright, what's A over 2A? A half. See how A over 2A, that's 1/2. Oh, fractions. Alright, cosine of 30 is going to equal the sine of 60. But what is it? Just 2? Square root of 3 over 2. Square root of 3 over 2. And then let's just look at the tangent of 30, and then we'll look at the tangent of 60. The tangent of 30 is going to be, here's what you have. Let me show you the outline. Opposite over adjacent. So basically you have 1 over the square root of 3. You do remember that square root of 3 is not allowed. So you multiply by square root of 3, square root of 3. So your tangent of 30 is square root of 3 over 3. Tangent of 60 comes from the other direction now. It's just the square root of 3. That is all.
Can you show the next one the cosine of 30 degrees equals
If I'm standing on 30, adjacent is A times the square root of 3, and the hypotenuse is 2A. So it's the square root of 3 over 2. Those are going to be used so often, these need to be memorized. We're going to make a unit circle that's built off of these two triangles. So, know them, learn them, memorize them. Love them.